All right, so maybe one type of thing you're asked is to find KEQ. The EQ just stands for equilibrium. It's a bit redundant with our K. However, the use of Q for reaction quotient and K for equilibrium constant is not universal. So some books will use K as not at equilibrium and then KEQ as at equilibrium. It just depends whatever you're using. Here we're going to talk about K as at equilibrium, Q not at equilibrium. So KEQ, a bit redundant, but whatever. So let's take a look at what we're looking at. We're talking about two SO2s combining with an O2 to turn into two SO3. And so if we want to find KEQ, we need to know the concentrations at equilibrium. And in this problem, these are given to us, right? So this data would be given to you, right? So it's giving you the concentration of SO2 at equilibrium to be 0.90 molar. The concentration of O2 to be equal to 0.35 molar, and then the concentration of SO3 to be equal to 1.1 molar. And so we want to find K or KEQ. It doesn't really matter which one you put. We remember that it's always products taken to their exponents over the reactants taken to their exponents. And in this case, we only have one product, and it's SO3. And it has a 2 as the coefficient, so we put a 2 there. And then the reactants, we have O2. This has no coefficient, so we don't put a coefficient there. And then, or it has a coefficient of 1, so you leave a 1 there, which you don't have to write explicitly. And then we have SO2. This has a 2 in front of it, so we put a 2 up here. And now, since we're given the concentrations at equilibrium, all we have to do is plug these numbers in and chug it through, right? So for SO3, we put in 0.9. For O2, we put in 0.35. And then for whoops, you see I messed that up. You got to be careful. SO2 and SO3, my bad. SO3 is 1.1 molar. And then SO2 is 0.9 molar. So plug those in. 1.1 squared over 0.35 times 0.90 squared. Plug through, do the math, and you should get a value of 4.3. Remember that K is unitless, and so it gets no units.